So the question here is asking us how long the water is above 5 metres. So 5 metres above low tide. So first of all, what we need to do is we need to work out what height, what amplitude that is going to be, because that there is 3.7, so therefore it's going to be a little bit up from there. So x naught, we'll call it, is equal to 5 minus 3.7, which equals 1.3 metres. So what we want to know is that there is 3.7, this here is 1.3. What we want to know is how long is it above that height there. So there's these two times here, there's this time here and this time here. So what we've got to do is we've got to work those ones out. Now the easiest one to work out is this one here, if I call this T1. Okay, so at T1, I'm going to go back to the equation we had before, which was x equals a sine omega t. We want to work out what t is. So x is the height at that particular point, which is 1.3 metres. The amplitude is 3.7. Sine omega, we've got omega from our previous question, which is 0.0001378 multiplied by T1. So rearrange this. So I'm going to get 1.3 divided by 3.7 equals sine of this decimal here, 1,2,3,1,3,7,8 T1. Now, if you got the wrong answer for this, this is maybe one of the parts that you got wrong, is the fact that this is in radians per second. So when we do arc sine, or sine to the minus 1 of this, we need to make sure that our calculator is in radians. So when you take the arc sine of this term down here, you should get 0.359 radians, and that is equal to this term we've got in here, which is 0.0001378 T1. Rearranging for T1, T1 equals 0.359 divided by 0.0001378. So I type that into my calculator and I get 2,605 seconds. So that there is equal to 2,605 seconds. The next thing, because we want to know how long it is above 5 metres from low tide, or how long it is above 1.3, we need to work out this time here, which we'll type in T2. Now whenever you type in sine to the minus 1, you always get the lowest possible value out of your calculator. So using your calculator to work out what is T2, you can't do it by just taking arc sine. It won't give you every value for which that is true. The easiest way to do this is to use the symmetry of the graph we have here. So if we look at this point here, this is 45,600 seconds. So that's that point there. So if we halve that, what we get is we get 22,800 seconds. Okay, so that's a midpoint of our cycle. This graph here is symmetrical. It's not come out particularly clearly on my graph, but if that distance there is 2,605 seconds, that distance there is also 2,605 seconds. That means that this T2 therefore equals 22,800 seconds minus that length there, which is 2,605. So that gives me 20,195. So T2 is 20,195 seconds. So we want to know the time that the water is above x equals 1.3 meters, and that is equal to T2 minus T1, which is 20,195 minus 2,605, which is 17,590 seconds. The question does answer it in seconds. You can obviously convert that into hours and minutes. It's just under 5 hours for that part there.